one of the things I want to talk to you about is choosing a Z or a T. And so we've talked about a couple of different statistics that we can use to figure out what our distribution looks like and to try to figure out what our placement looks like on the normal curve. And we're basically end up with a Z distribution, or we end up with a T distribution or a student distribution. In the case of the Z distribution, we know that things are normal, so we don't have to approximate anything. In the case of a T distribution, this is an approximation. So we don't know for sure that things are normal, and so we're trying to approximate T. None of that should be particularly surprising. So we've got to figure out in what circumstance, why isn't this erasing? Under what circumstance do we use T or Z? And this map is our way to figure that out. So the first thing you need to ask yourselves when we're in this situation is, do we know sigma? So this is the first thing here, okay? Do we know sigma? If we know sigma, then we can assume that because sigma is the standard deviation of a population, then we've already calculated the population. We know what sigma looks like. Therefore, we know whether or not things are normal, and we can assume that they are because we have a sigma. The mere fact that we have sigma means that we have a calculation for a normal distribution. So we go left. All right, no surprise there. And then we ask the next question: is the population normally distributed, or is the sample size at least 30? Well, we have to know that the population is big enough to justify our Z. And so, do we know that it's normally distributed? Sometimes in a question you'll hear a thing that says, we know it's normally distributed. Well, then you're good to go. And if it's not, or we don't know, then you look at N. Is N equal to or greater than 30? That's what we're saying here. Is it? If it is, let me get rid of that. If it is, then we use the normal distribution. This is a Z. All right, fantastic. If it's not, then it doesn't really apply for a traditional Stats 101 class, or in this case 2341. This will do more of this stuff in grad school and that kind of thing, or in an advanced stats class. All right. If you don't know sigma, if we're going the other way now, we're going this way. If we don't know sigma, then we have to ask the question, is it normally distributed, or do we have a large sample size? If it is not, then same thing, more advanced techniques, we're not going to worry about that, right? If it's normally distributed, or we have at least a 30 sample size, we can keep going. Then do we have enough observations? N is equal to 30. If it is, then remember this guy over here, right? At least 30. If it is, then we can assume that the T distribution looks good. It looks close. We're going to do a Z. If it's not, if we don't have 30, then we use a T. Let me change the color for the sake of effects. And we have a T over here. T distribution. That looks terrible. We have a T distribution. Okay, so here's where we're going to end up. You use a T when we don't have 30. We use a T when we don't know sigma. If you know sigma, then we go left, and we're going to end up at Z, hopefully. If we don't know sigma, but we have this 30, then we can still maybe end up at Z. These are the three basic situations that you're going to get into when you make these calculations between a normal distribution and a student distribution, or an approximation of the normal, between the Z calculation and a T calculation. And the obvious difference is that the Z is going to put you on one table when you find probabilities or area under the curve, and the T is going to put you on a different table when you find probabilities and area under the curve. All right.